All right, so we're still in Unit 3, Lesson 6. So we have entire radicals and mixed radicals, so Part 1. So recall from your last lesson, the product of the roots of two numbers is equal to the root of the product. So that just means in terms of that means you can multiply radicals. So like right here, root A times root B is root A times B. You can put them together, that's okay. Okay, the sum and difference is not equal, so you cannot do subtraction. You cannot go root A minus root B and have root A minus root B. You can't do that. Okay, so, and this is from yesterday, and then multiplication and division are okay. Okay, they both work, just as long as B is greater than 0, because we can't divide by 0. All right, so that's just a little review, and that wasn't the main point of the last lesson, but it's okay. So write the following as a product of or quotient of radicals. So this wants me to finish this. So if I have 24, 4 times what's 24? 6, so then I can break this up to root 4 and root 6. Okay, 18 is 9 times 2, so I can break this up into root 9, root 2. Okay, now what do you notice about these though? We're doing this for a purpose, but what's the square root of 4? So you can write it 2 root 6. That's how you can write it simplified. Yeah, because root 4 is 2. Same thing here, what's square root of 9? 3 root 2. That's how you get, that's what we call a mixed radical, 3 root 2. Okay, this right here is an entire radical. This right here is a mixed radical. Kind of like a mixed number, right? Okay, anything yet? No dice? Okay, square root of 11 4 is the same thing as root 11 over root 4. Okay, we know that root 4 again is 2, so we can simplify it as root 11 over 2. Square root of 4 is 2. There's 11 is not a perfect square. Okay, so then using your calculator, we're going to approximate these here. You're going to kind of see the pattern here. But so real quickly in your calculator, give you about 30 seconds. Just punch these in and see what you get. Yeah. Go to 4 decimal places. Sure. Or it says 5, sorry. 4, 4, 2, 7. So what do you notice? They're all the same. So all of those radicals are the same in terms of their value. We're going to talk about right here at the bottom why they're the same. Okay? So 4 times 20 we can break into 4 root 20. And that gives me 2 root 20. So we got from root 80 to 2 root 20. So they're the same. So that's why these two are the same. Now we're going to go from root 80 to the next step. 16 times 5. Root 16 is 4 root 5. That's all the same. So essentially, all these are simplifications of the same problem. Root 80 can break down to 2 root 20. Root 80 can also break down to 4 root 5. Okay, let's go ahead and fill in the gap. How can we get from here to here? What can I break 20 up into? 10 doesn't help me, but that's a good idea. 5 and what? 4. We like 4s, right? So I could go 2 times 4 times root 5, right? What's the square root of 4? What's 2 times 2? And we come back to, we kind of connect the dots of how that became. Okay, so they're all simplifications of each other. All right, so like I said above, right here, 80 is an example of an entire radical, which means non-simplified. Okay, 2 root 20 and 4 root 5 are examples of mixed radicals, or radicals that are somewhat simplified. I guess 2 root 20 could be simplified more, but you get the idea. All right, let's move on here to the next page. All right, so entire pure radicals, radicals in the form of root 25, root 80, cube root 17. Mixed radicals in the form of having a number in front. So the only difference is nothing in front has a whole number in front, or been somewhat simplified. Okay. So now what we're learning how to do today, and this is a very, again, in Math 20, you are going to be asked to be able to break down radicals really, really well, okay? And you're going to kind of learn the basis of that today. So today is kind of the foundation for your radicals learning. I mean, how much did we do in radicals in Math 9? Do you guys remember? Not very many, right? So it's a fairly new idea. We did square rooting. I remember that, right? Okay. So an entire radical of index 2 may be expressed as a mixed radical when the highest perfect square has been factored out of the entire radical. And so this is how I teach it. Okay? Some people do a thing where they break it down. It takes 2 to get out, and it works. But I like quick, effective ways. Okay? So the easiest way for me is right now, without looking at this list here. Okay? Can anybody tell me the biggest perfect square that goes into 108? Okay, so you have a 36, but how, I mean, that was really good, Josie. Okay, how quickly do you think you could have gotten that for, like, 450? What if I said 450? The biggest perfect square that goes into it. Nope, but close. Okay, see, but my point is, you're getting away from my point here. I'm not asking you to be that sharp with it. What I want you to try to do is, I think the easiest thing to do is to take, what's half of 108? 54, right? So 54 is between those two numbers, right? Yeah. So then I like to just work my way back and try to find the biggest perfect square. So you would have tried 49, it wouldn't have worked. You would have tried 36, you would have had it. Okay? So that's kind of my set points. Let me say it one more time. I like to take half the number I'm going for, okay? And I like to work back until I find the biggest one. Because what a lot of people do, and this, I'm sure you might do this at some point, they tell me, oh, I broke this down to 4 times 27. Because 4 is a perfect square, right? But the problem is 27 has a perfect square as well. And so now you have 2 steps to do. Okay? So that's why it's important to have the biggest perfect square, 36. Okay? So we'll get to that in a second, but that's just my way of doing it. If you don't like it, we can talk about something else. So 36 times 3 is what we want. We break the 36 off and the 3 off. Square root 36 is 6. So root 108 as a mixed radical is 6 root 3. If you put square root of 108 in your calculator, you're going to get the same thing as if you put 6 root 3 in your calculator. Is there any questions on this? Okay, and like I've told you last class, I expect you to have 1 through 15 pretty much memorized in terms of your perfect squares. You shouldn't need a calculator to figure out these numbers. They should be automatic by the end of this unit. Okay? Any questions? Because it's the foundation. This is very important in terms of your conceptual understanding. So if there's any gray area or confusion, all right, we'll try some examples then. Okay, convert the following radicals to mixed radicals, which by convert that means break down. I call it say break down. What is the biggest perfect square that goes into 50? Well, let's do the method. It might be easy. If you already got it, good. What's half of 50? It's 25 perfect square. Right, and so it is perfect square. So we actually landed right on 25. So we want to break this down to 25 times 2. That's the biggest possible perfect square that goes into it. Okay, and so what that breaks it into is 25 times root 2, and that gives you 5 root 2. Square root 25 is 5, like Mike just said. Okay? All right, so 45. Okay, 45. Oh, let's do the half thing. What's half 45? It's 22.5. So that means I'm going to try 16, and I'm going to try the 9. Does 16 go into 45? No, but 9 does. So there it is. I want 9. It's 9 times 5. And some of these you're going to get really good at. Some of these you don't have to do my method the whole time because you're going to get the number sense. You're going to figure it out. Okay? I like to use it for like 320 is a good one to use it for. We're probably not sharp on 320. Okay? At least I'm not. Josie might be. Okay? All right. So the 9 comes out as a 3. So you have 3 root 5 for this answer. All right, so 320. 160 is half. So then what are my perfect squares from that then? 144. Does that one work? Okay, and what do we have after that? 121. Does that work? Okay. We know 100 doesn't work. We have to try 100. How about 81? Just misses, doesn't it? Okay, how about 64? Yeah, so 64 times 5. And again, with your number sense, you'll kind of get patterns of ones you know that aren't going to work. Like I would not have tried 121. This wasn't my first time. Okay, I wouldn't have tried 144 either. Okay, because 144 times 2 is 288. I'm going to overshoot by far. Like it's not going to come close. Okay, so there's some that you, again, as you do these, it won't take as long. 8 root 5 is that answer. The 64 comes out as an 8. Okay, got a couple more here. Have we got this? Good to go? All right. All right, so this one here, convert the following radicals to mixed radicals in simplest form. So what are we going to do with the number already out there? Good boy, Mike. If there's something already out there and you pull something out, you're going to times it. Okay, and I'll show you why in a second. But let's break down 192. So half of 192 is... no, it's not 140. 96. So then, I know 81's probably not going to work. It's too big. So 64? 64 times 3, huh? So 64 times 3. Now, this is why you have to multiply. Okay, some people don't realize this. Do we understand we just did this, right? And the 2's still there. What are they all doing? They're all 3 of them are multiplying. And then the 64 changes to a 8. See, now what's 2 times 8? So then it's 16 root 3 is how that works. Now, you don't have to do all that work every time. That's right there, a demonstration of why we have to multiply them. Questions on that? I wouldn't. If you want to, you can, but I mean, I wouldn't. Because what if something comes out that's like 40? I can cancel the 4 pretty easily. But you can, if you're 0.75, I mean, whatever you want to do. All right, how about here? 160. Well, we could half it. Okay, it's 80. But then I got to think, 160 has definitely a 16 in it, right? So I'm going to skip right to 16 times 10. That's a number sense right there. Because 10, the way you can check if you're right, does 10 have any perfect squares in it? 1, 2, 5, and 10. Now those are perfect squares, so I know that's the biggest one. Okay? So 16 and 10. And then like I just told Mike to wait, okay, root 16 is what? 4. What happens to the 4s? They cancel. So your answer is 3 root 10. Whoa. Mind blown. The what? The 4's canceling? Yeah. So you don't understand why they cancel? All right. Quick little fraction lesson for some of us here. 3/4 times 4 is the same thing as 3/4 times 4 over 1. Okay. They cancel because they're on top and one's on bottom. What's 4 over 4? 1. So it cancels because of that. If you don't believe me because of that, fine. Then do it across. 12 over 4. What's 12 divided by 4? Still 3. Okay, and we have square root 7 over 9. So we're going to use our root 7 over root 9. We break it up. Okay, and then we get root 7 over 3, and it wants us to write as a mixed radical, so how can I just write that a little different so it's a mixed radical, so there's a number in front? 1/3, yeah. 1/3 root 7. Like that. That's the same thing. Very good, very good. Okay, and now just for understanding, we're going to go backwards. We're going to take mixed radicals and we're going to change them to entire, which probably is a little bit easier. Okay, so for a quick example here, we're going to take 3 root 14 and we're going to make it mixed. Okay, or excuse me, we're going to make it entire from mixed. So if a 3, I want to make that into a radical, that's going to be root what? 9, because 3 squared is 9. Okay, and then I'm going to go 9 times 14. And that's going to give me, I think, 126. 126 square rooted. Oops, it's supposed to be right here. Oh, no, that's right. Okay. So quickly, I can remember really quickly, all you do is the number for mixed to entire, you take that number, you square it, and you put it in a radical. Okay, so then right here, I'm going to take 2, I'm going to square it. That's going to be root 4 times root 5. What's 4 times 5? Root 20. What's that? You like that better? Yeah, it's a little bit easier. Okay. This one here, 4 squared is 16, so I get root 16 times root 7. Okay, that's going to give me root 112, 16 times 7. Okay, you still following? All right, and then the last one here, 10 squared is 100, so root 100 times root 6 gives me root 600. 6 times 100. All right, just got a couple more sets of examples here, and then we'll be done. Okay. All right, so for the following mixed radicals to entire radicals. So now it's a fraction, it's 3 halves. I want to square that. So how do I square 3 halves? Square top and bottom. Good. Okay, that's going to make what? 9 over 4. So root 9/4 times 8. Yep, 18. So you're going to have 9 times 8, 72, divided by 4 is 18. So that's going to be root 18. Got it? Okay, I'm going to square 0.4. That's going to give me 0.16. I'm going to times that by 50. 50 times 0.16. That's going to give me 8. Just kind of calculator work there in terms of 50 times 0.16. Okay, so here, the negative you're not going to touch. The negative is going to stay out because we can't push the negative into the radical. Okay, so your negative is going to stay. You're just going to handle the 5. So 5 squared is 25. So it's going to be negative root 25 times root 7, just like that. So negative just kind of hangs out. And then your 25 times your root 7 is negative 175. Root 175. All right. Okay, last page here. 2 more examples. Any questions? Smooth sailing? All right. Okay. Example 6 and 7, last 2. All right, so 6 says, without using a calculator, arrange the following mixed radicals in order from greatest to least. Not leastest. Least. Okay? 3 root 5, 5 root 3, root 15, 2 root 8, and 8 root 2. So let's order those. Well, what would probably be the can. Like, this is broken up best it can be, but we probably could make it a entire radical, and we could see it a lot easier. So what is 3 squared? So root 9 times root 5 is the root 45. Okay, so the easiest way to do this is to just look at all in terms of entire radicals. This here, 25 times root 3. Wow, this one's a lot bigger than that one. Root 75 is a lot bigger than root 45. Root 15 is really small. We'll just leave him root 15. 2 squared is 4 times root 8, that's root 32. So that's not that big. And then we got a really big one here. 64 times 2 is 128. Okay, so here we go. This is my biggest, my second biggest, third, fourth, fifth. We use entire radicals to help us because I made them all the same radical type. All right, home stretch. So use the Pythagorean theorem to determine the exact length of A and B. Express the answers as an exact value in simplest mixed radical form and as a decimal. So we want to figure out what A and B is. Excuse me. So we're missing. We need to figure out what this is to figure out what AB is. So first thing I have to figure out what AD is. So I'm going to go Pythagorean theorem. So I'm going to go, we'll call this X. So X squared plus 8 squared equals 12 squared. I'm trying to figure out what X is. That gives me X squared plus 64 equals 144. Minus X squared equals 80. So X equals square root 80 for the last step. So we'll leave that like that for now. So now I have the two legs to figure out what A and B is. So now I'm going to go 6 squared plus root 80 squared equals AB squared. Slow down for a second. Let me know if you have a question. We're good? Okay, 6 squared is 36. Root 80 squared is 80. Equals AB squared. That gives me 116. It says express the answer as in a mixed radical, so we want to see if we can break 116 down. So we're going to have AB equals square root 116. So we want to see if we can break square root of 116 down. What's the biggest perfect square that goes into 116? Is that a 116? Yeah. It's not a perfect square, though. So this one's actually the smallest one, actually, ends up working as 4. And when you try 4, it breaks down to 4 times 29. Well, 29 has no perfect squares. 29 is prime. 29 and 1, right? So we know that's going to work. So AB, what's the 4 come out as? So AB, in terms of mixed radical, is 2 root 29. Okay, and then go ahead and punch in your calculator to get the decimal like it asks for part B. That's part A. And then part B. Sorry, I'm writing really bad here at the bottom. What is it? 10.77. That's it. All right, so go ahead and work on your practice. If you'd like to work on your project after, like, split the time or work on your project for, like, the first, 20 minutes and then work on your practice second, you can. Okay, however you want to cut it up.